Okay, so as you guys can see from the warm up, a lot of the work that we're going to do today is going to revolve around adding or subtracting fractions. So let's talk about what needs to happen in order for us to be able to add and subtract fractions. So I'll let you guys know ahead right now that you will need a common denominator. You cannot add or subtract fractions unless you have a common denominator. Now, something like 8 plus negative 3, obviously, these two fractions have the same denominator of 11. So if we were to solve this, what would we get? What is 8 minus 3? 5. So we get 5. Now, here's the tricky part. Is it 11 minus 11 and then my denominator is 0? Or is it 11 plus 11 and then my denominator is 22? No. What happens to the denominator? Stays the same. So one analogy that I like to think about is the pizza analogy. I know it would be a weird pizza to have 11 slices, but think about a pizza with 11 slices. Somebody buys a pizza with 11 slices, and by the time you get to the pizza box, there's only 8 slices left. Somebody else had 3, but ignore those 3. Of the 8 slices remaining, you grab 3 slices. So there's 5 slices now. But how many slices were there originally? 11 slices. So that's why I want you guys to kind of think about denominator doesn't change. It's not that you take 3 slices and all of a sudden there were 22 to begin, or there were no slices to begin with, right? Um, so yeah. Anyway, moving on to problem B, x over 6 plus 2 over 6. You will notice that we have the same denominator. So we should be able to just combine the numerators. X plus 2 is not 2x. Okay, I see a lot of people making this mistake. X plus 2 is not 2x. Why would an x plus 2 equal 2x? Sophia? Either multiply them. Well, actually, we multiply them, we'd get x squared. We could add them to get 2x, but then you'd have to add x plus x. And x plus x would be 2x's, but that's not the case. This is x plus 2. So you just keep it as x plus 2, like that, over 6. Okay? So you're just combining it under a single denominator. Now, here comes the fun part with problem C, which is what happens when you don't have a common denominator? Because now we have to find one. So we have to think about the least common multiple. This is known as LCM, the least common multiple. So you're looking for a multiple between 3 and 5, and you're thinking about the first one that is shared by them. Now I want you guys to think about multiples as multiplying your number. You're not dividing it out. You're not looking for factors. A factor is something that goes into your number. No, we're looking for a number like when you multiply it out. For example, let's start with the 3. What are the multiples of 3? We have 3, 6. What else? 9, 12, 15, 18, and so on and so forth. These are multiples. Let's talk about multiples of 5 now. 5, what comes after 5? 10, 15, 20. What number is shared by both 3 and 5? 15. So our least common multiple will be 15. Okay? This is different than a factor. A factor, like I just said earlier, a factor is something that goes into the number. If we think about factors of 3 and 5, the only factor for 3 and 5 would be 1. Okay? Because 1 goes into 3, 1 goes into 5. But multiples, we were actually like, drawing it out, finding like when you multiply it out. So anyway, we identify the least common multiple, and we're going to label that our least common denominator. That means that we need a denominator of 15. So we want to turn our original fractions into equivalent fractions with a denominator of 15. Equivalent meaning you're going to find some number to multiply the top and bottom by to get a denominator of 15. And since you're multiplying the top as well, then it's going to give you an equivalent fraction. So let's talk about 1 over 3. What am I supposed to multiply 3 by to get 15? By 5. So I have 1 over 3 times 5 over 5 plus 2 over 5. What am I going to multiply 5 by to get 15? 5 times 3. So we're going to multiply this by 3 over 3. Okay? Now, I'm not making math up. I'm not making stuff up right here. 5 over 5 is equal to 1. So technically, I'm not changing anything. 3 over 3 is equal to 1. So really, I'm not changing anything. The goal of this is equivalent fractions. 1 over 3 times 5 over 5 is 5 over 15. 2 times 3 is 6. 5 times 3 is 15. So we have 5 fifteenths plus 6 fifteenths. And so we consolidate this and we get a solution of 11 over 15. Now, think of the steps that we just did, the steps involved in this process. We are going to repeat these like steps, but instead of basic, 1/3 plus 2/5, instead of that, it'll be x plus 2 over x squared plus 7x plus this plus that. Like it's going to be a bunch of variables. But the process will be the same. You will still need to find a common denominator. Okay? All right. Any questions on the warm-up before we move on? I'm going to try to take my time throughout the lesson today, so maybe we'll finish, maybe we won't. I don't know. But I want to make sure you guys are following along and making sure that you're understanding, okay? So let's look at the first activity of the day, which is a partner task. I will be doing the first one with you guys, and then we'll get you guys started on that. So give me 1 second while I set this up. So like I was saying, partner task. So we want to examine each expression below, and for each one, assume that no denominator is equal to 0. Obviously, if that were true, then we get undefined. You want to use your understanding of adding fractions to add the algebraic expressions. Simplify your final response if possible. So like I said, I'm going to help you guys with the first one, just to kind of model what it is that I want you to do with your partner. So basing ourselves off of what we did for the warm-up, it is vital that we have a common denominator to be able to combine two different fractions. In example A, do we have a common denominator? Yes. So we can go ahead and just add. We can add the top together. So let's go ahead and do that. 2x plus 7, when we combine it, will just be 2x plus 7. We will then have our denominator 2x squared plus x minus 21. Now, don't forget, we need to simplify your final response. So look at 2x plus 7. Is 2x plus 7 factorable? Can we do anything with 2x plus 7? Like, is there a factor we can take out of 2 that also goes into 7? No. However, look at the bottom, 2x squared plus x minus 21. We are going to use the Xbox method to factor the bottom. So let's go ahead and do that at this time. We will do the product of 2 and negative 21. That'll be negative 42 x squared. And then this is supposed to add to 1x. So we're looking for two numbers that multiply to negative 42 and add to 1. Think of the single-digit numbers that multiply to 42. What two numbers multiply to 42? 7 and 6 will make that a negative 6. 7 and negative 6. We can go ahead and create our box at this time. Fill in your box with 2x squared and negative 21. Then you can add your negative 6x and 7x. Now think about what we would need to do to fill out the box. what can we take out from 2x squared and negative 6x? What is a factor of 2x squared and negative 6x? 2x. What goes into 7 that goes into 21? 3 doesn't go into 7. 7 goes into 7. 3 goes into 21. So we have our two factors, 2x plus 7x minus 3. So we'll go ahead and rewrite our original kind of fraction, 2x plus 7 over 2x plus 7 x minus 3. Can we do anything here to factor out or to cancel anything out? And if so, what can we cancel out? 2x plus 7. So we can cancel this with this. Another side note, some people were struggling on the quiz because they had something like this where it's like the top and the bottom canceled out and you're left with something in the bottom. If you're left with an answer that is in the denominator, you need to place 1 as a numerator. It's like a placeholder. So your answer is not just x minus 3 in this case, but it would be the fraction 1 over x minus 3. So that would be our simplest answer. All right. So this is the first one. I'm going to give you about 12 minutes to complete B, C, and D. And I know what you're going to say. You're going to say, that's not fair. You did the easiest one. The other ones you have to factor out. They might be a little longer, but it's still doable. So 12 minutes start now. Go ahead and continue working, or go ahead and start working with a partner or somebody next to you. Microphone was off, so whatever. Okay, anyway, we combine like terms, so 3x plus 9 minus x minus 4, we get 2x plus 5 and 8x squared minus 50. So the bottom is looking a lot like a difference of squares, but we can't do a difference of squares just yet. We have to actually factor a 2 out. So we'll do 2x plus 5. We factor a 2, and that'll give us 4x squared minus 25. Now, 4x squared and 25, these are perfect squares, so we are going to be doing a difference of squares on that. that will give us the following: 2x plus 5 over 2 parentheses 2x plus 5, 2x minus 5. And so now we can start to look at things that we can cancel out. And what do you guys see? What can we cancel out? Yes, Dylan. 2x plus 5. Good. So we can take this out and we can take this out. And that's going to give us 1 over 2 parentheses 2x minus 5. Yes. Mm-hmm. Mm-hmm. That's instead of doing the distributive part. Oh yeah, yeah. I mean, of course. Yeah, you can skip that step. I just did the step with the distributive part, just so you guys could kind of see how we are supposed to get 2x plus 5. Some people mistake that minus and think it's only for the x. All right. Last example before we move on. This one looks very difficult, but once you start adding things together, you'll notice that you get 3x squared plus 2x minus 8 over 3x squared plus 2x minus 8. And do we even need to do anything with this, or can we just cancel it out? We can just go cancel it out. We have the same thing on top and the same thing on bottom, which is going to give you a result of 1. All right, so that one was an easy one. All right, any questions on the partner task? Okay, I'm going to show you one example for the team task, and then you'll have 3 to work on with your team, and then we'll take our break. Okay, so we're almost at our break. All right, so let's go ahead and move down to the next page, and we're now going to see what happens when you don't have a common denominator. Okay, it's going to start to get a little difficult. This is where I start to lose people. Okay, so we need to identify the least common denominator based on these 2 denominators here. And one of the first things you got to look at is numerically, what is the least common multiple? So you have 2 numbers. You have 4 and you have 8. What is the least common multiple between 4 and 8? And if you need to write it out, you can do that. So 4, 8, 12, 16, 8, 16, 24. Look at my list of numbers. What is the least common multiple? The first number that comes up in the list. Not 16, it is 8. 8. So we have an 8 right there and an 8 right here. So for our least common denominator, we have 8. Now let's look at the variables. What does the first what does the first denominator have, variable-wise, that the second denominator doesn't have? It has an x, so we need to include that. It has an x. Same question, but now I'm going to pose it differently. What does the second denominator have that the first denominator doesn't have? An extra what? An extra y. So that means we need 2 y's. So our LCD is 8xy squared. So you're going to turn each fraction so that it has a denominator of 8xy squared. Okay? So let's start with the fraction 3 over 4xy. What do we have to multiply 4xy to get 8xy squared? Well, first, 4 times what gives you 8? 4 times 2 gives you 8. Do I need any more x's to get 8xy squared? No. But do I need more y's? Yes, I need 1 more y. So I'm going to multiply top and bottom by 2y. All right. Then we have 5x over 8y squared. What are we missing to get our denominator to look like 8xy squared? We already have 8, so we don't need to multiply by any other numbers. We already have a y squared, but we're missing what? An x. So we're going to multiply top and bottom by x. And then we're going to rewrite that down here. 3 times 2 is 6. We have 6y over 8xy squared. Six y minus 5x times x is 5x squared. We have 6y minus 5x squared over 8xy squared. And we can't do anything there with the top or the bottom, so we just leave it as is. Okay. All right. Fun stuff. You have 11 minutes to complete the other 3 problems. Go ahead and get started. Okay, some people have been struggling to get started on problem B, so let me help you set this up. Please follow along because you can kind of repeat this for letter problem C. So anyway, we need to start by identifying the least common denominator. That is the first step for all these problems, is to find your LCD. Essentially, your least common denominator will be a blend of both of your denominators. For example, what does the second denominator have that the first denominator is missing? The x minus 5. So that means for your least common denominator, you want it to be x minus 5 times 3x plus 1. Right? That, because our second fraction already has that, we don't need to do anything to our second fraction. However, since our first fraction is missing x minus 5, that means we have to multiply our first fraction by x minus 5 over x minus 5. So that's going to give us x squared minus 5x over x minus 5 times 3x plus 1. And keep in mind, this is just the first fraction. We can now go ahead and add 2x squared minus 2 over the same denominator. So we still have x minus 5, 3x plus 1. At this point, we can combine like terms. So x squared with 2x squared. And that'll give us following: 3x squared minus 5x minus 2 over x minus 5, 3x plus 1. And I don't know about you guys, but that top is looking factorable to me, so we might have to factor it out. 3x squared minus 5x minus 2. We can write that as, let's see, numbers that multiply to negative 6 that add to 5, 6, and 1. So yeah, we can't do that actually. Some Xbox method over here, so I'll do it down here. Negative 6 and negative 5, that'll be negative 6 and 1. So we can factor the top to 3x plus 1 times x minus 2 over x minus 5, 3x plus 1. And now we can cancel. What? Oh, yeah, yeah. X minus 2 over X minus 1. So just a little combination of everything we've seen up to this point. Okay. I'll leave this up. You guys can continue working. Problem C, 9 minus 3x over x plus 3x minus 3 plus 2x over x plus 3. So remember that we have to identify the least common denominator, the LCD. And when it comes to having factors like this, you're basically going to do a blend of the two factors. So you're going to identify kind of what we have and what we're missing. If you look at the first denominator, we have the two factors x plus 3, x minus 3. Whereas for the second denominator, we only have x plus 3, so we are missing the x minus 3. So we'll go ahead and make our LCD the first denominator, since at least we have something in common. And that means we'll multiply the second fraction by x minus 3 over x minus 3. Okay? So that'll give us 9 minus 3x plus, we need to distribute the 2x to x and minus 3. So that'll give us 2x squared minus 6x, all of that over x plus 3, x minus 3. Okay. So at this point, we will need to combine like terms. Excuse me. So that'll be negative 3x and negative 6x that we're adding together. We'll go ahead and put that, and we'll get 2x squared minus 9x plus 9 over x plus 3, x minus 3. With this trinomial 2x squared minus 9x plus 9, we do have to do x box method on, which I'll kind of do here on the side. Let's take a look. So that's 18 and negative 9, so negative 6 and negative 3. We complete our box. 2x squared and 9, negative 6x, and negative 3x. So we'll get 2x minus 3 and x minus 3. So I'm going to write that over here on the side. We'll have 2x minus 3, x minus 3 over x plus 3, x minus 3. Am I going too fast, you guys? No, kind of. Let's zoom in. We can then go ahead and cancel out the x minus 3 over x minus 3, giving us a final answer of 2x minus 3 over x plus 3. Yep. So it's pretty easy. Well, not easy. It's more manageable when you already have factors. You will see in the next problem just how much extra work we have to do when you don't have it already factored for you. I haven't made the quiz Friday, but when I make it, I'll make it so it's not like super extra hard. I'll like just something manageable, something kind of like this. Maybe not so many Xbox method, or we'll see. Okay, let's jump to the last one, and then we can go do our appointment book. So x minus 1 over x squared plus 4x plus 3 plus x over x squared minus 9. So we will need to factor out our denominators, both of them. And so for the first denominator, that'll be the x method, and that'll be 3 and 4 in our giant X. Two numbers that multiply to 3 and add to 4 will be 3 and 1. You don't need to do the x. Sorry, you don't need to do the box. Just the x is fine. We'll have the two factors x plus 3 and x plus 1. And then for our second denominator, x squared minus 9, this is a difference of squares. We'll have x plus 3 and x minus 3. Okay. Now we have to identify the common factors between these because we need to figure out what the LCD will be. So look at both of our factored forms. What is a factor that is already shared by our two denominators? X plus 3 is already shared by both of these. What are we missing? Well, we are missing for one of the denominators, we're missing the x minus 3, and for the other one, we're missing the x plus 1. And so our LCD will be all three of these. Okay? So we'll make the LCD a combination of x plus 3, x minus 3, and x plus 1. Okay, so this is where things start to get a little ugly because we got to multiply our first fraction by, we said we were missing x minus 3. So we'll do x minus 1 over x plus 3, x plus 1. We're going to multiply these top and bottom by x minus 3 over x minus 3. And then plus, we have x over x plus 3, x minus 3. And the second one, you're going to multiply by x plus 1. So this is what we're doing here. Which I know seems like a lot of work. So, yeah. All right. X minus 1 times x plus 3, or x minus 3, will give us x squared minus 4x plus 3 plus x squared plus x. So I'm kind of putting everything together at this point. Over x plus 3, x plus 1, x minus 3. And we're almost done. We just got to put everything together. Two x squared minus 3x plus 3 over x plus 3, x plus 1, x minus 3. Lucky for us, the top is not factorable, so we can stop there. And that's it. That's all you have to do. Yes. Oh, it's gonna do its thing right now. It's just gonna take a while. I know this looks hard. It gets harder. If not, I mean, believe me, pre-calc, you're gonna see this again, right, Yuri? Yeah, and you probably see it like way harder than this. So, so yeah, I'm gonna reset the screen so you guys can see what I got. But if you're done copying it down, then we'll get started in the appointment book shortly. Give me 1 second.